All right, so as we look at the time value of money, okay, so time value of money. So we have what we call finding the compound interest. Okay, so on the aspect of creating the compound interest, on the compound interest for a single deposit, okay, so single deposit, we have the future value of any deposit is equal to present value, then 1 plus R to the power n. So our n is the number of years, then FB is the future value. FB is equal to future value. Okay, then our n is the number of years. All right, so this is what we have. Okay, so from here, then our R is interest rate. Okay, so this is what goes on. All right, so we can now finding the present value is equal to future value, then 1 plus R to the power negative n. Okay, so this is what we have here. Okay, so okay, then when we get down to the question here, okay, so we can do some questions here. So an example, question 1.12, we want to have exactly 8,000 in your account at the end of 5 years. So at the end of 5 years, want to have how much? 8,000 at the end of 5 years. Then the account allows you to make one deposit at the beginning of each year at an interest of 8%. So in order to have 8,000 at the end of 5 years, how much you must make the new deposit each year? So that this one becomes an annuity because it's a series of equal payment. Okay, so you want to have 8,000 at the end of 5 years. So if it's an annuity, it's a series of equal payments. So when you talk about annuities, we have there are two types of annuities, of course, right? So under annuities, okay, so we are simply saying series of equal payments. Okay. equal payments, or deposits. So we have ordinary annuity. So what is an ordinary annuity? So it's an annuity where payments are made at the end of each period. Okay, so simply say, okay, annuity where deposits, okay, so where deposits are made at end of each period. At end of each year or a period. Okay, so we have the future value interest factor of an annuity is equal to amount 1 plus r to the power n minus 1 over r. Okay, then we also have the present value interest factor of an annuity, which is an ordinary one, is equal to amount, okay, then 1 minus 1 plus r to the power negative n over r. So this is for ordinary annuities. Then we have the second annuity is called annuity due, right? Annuity due. So this is where payments are made at the beginning of each period. So payments made at beginning of each year or period. So we have future value interest factor annuity due. So it's equal to amount, then 1 plus r. So plus r to the power n minus 1 over r. Then you multiply by 1 plus r. Then the other one is present value interest fact annuity due is equal to amount 1 minus 1 plus r the power equal to n over r. Then you multiply by 1 plus r. Okay, so this is what goes on. All right. Okay, so then when we are looking at this amount, you want to have exactly 8,000 in the account at the end of 5 years. The account allows you to make one deposit at the beginning of each year. So what type of annuity is this? Hello, Madam Melissa, what type of annuity is this one?
It's an annuity due because you're making payment at the beginning of each year.
Thank you very much. You are right. Okay, so and what is going to happen now is that you use the formula, all right, which is okay. So now they want us. Okay, so how much must you deposit each year? So the future value is 8,000. So future value is 8,000. So we're going to use the formula up here. We're going to use this one here, this formula. So it will be 8,000, which is equal to our amount. We don't know, that's what we are looking for. Then the rate, how much was the rate? 9%. The rate is 9%. So 1.09. 1.09 to the power 5 minus 1 over the 0.09. Okay, then so this is an annuity due multiplied by 1.09. So this one gives us what? 1.09 to the power 5 minus 1 divided by 0.09 times 1.09. So this side, we are going to have 6.5233. And then this is 8,000. So 6.52 Okay, so 6.5233. Even here we divide by 6.5233. So how much are we talking about now?
It comes to 1,226.37.
All right, that is correct. 1, 2, then 0.37. So this is about the answer that we have found. All right. Okay, so that goes. This one goes. So anything else, you just need to use the formula. So then if annual interest is 10% for this other question, how long would you have to wait before 17.5 for it to double? So 17.5 to double, it will give us you use just that's a single deposit. So you use this formula. Future value is equal to present value 1 plus R to the power n. So 17.5 times 2, 35,000. Which is equal to 17.5 then 1 plus 0.1 to the power n. So you divide by 17.5 even here you divide by 17.5. You cancel this. So 2 is equal to 1.1 to the power n. So in this case, we introduce natural logarithms. So we just say log 2 is equal to n log 1.1. So divide by log 1.1. Okay, so divide by log 1.1. Even here, log 1.1. So our n is equal to log 2.
I have 7.27.
Yes, you are right. 7.27. So 7.27. All right, so that is what goes on. Okay. So it's just about using the formula. So a single deposit, and for all, what happens? You just manipulate the formula. So now, if you have gotten a loan of under loan amortization. All right. So under loan amortization, if you have gotten a loan of 200,000 kwacha, okay, from the bank, right? Or it can really be $1,000 dollars. Okay, let us look at this question. You can read this question for us. This question 11. Okay, so
Question 11.
uh-huh.
Prepare an where's starting from? Just from question 11 there?
Yes, yes.
Okay. Prepare an amortization schedule for a $1,000 loan to be paid in 3 equal installments at the end of each of the next 3 years. Interest is charged at a rate of 6% per annum. Should I continue just there?
Okay, yes, now that is okay. So now the under amortization, we look at the loan repayment. Okay, so we look at what we call periodic repayment. So on our periodic repayment, we look at our repayment is equal to amount of a loan multiplied by R over 1 minus 1 plus R. Okay, to the power negative n. So that's a formula for loan periodic repayment. Okay, so where A amount of the loan, so this is a loan amount. N is number of years. Then our R is the interest rate. Okay. So this is what goes on. All right. So using this formula, how much money did we, okay, how much is a loan amount from here? Our loan amount,
$1,000.
1,000, yes, for 3 equal payments, not so.
Yes.
So 3 equal payments. Yeah, so meaning that our payment would be 1,000 then multiply by 0.06 over 1 minus 1.06 1.06 to the power -3. So our repayment gives us what? 1000 times 0.06. So 1000 times 0.06 is 60 over 1.06 the power -3 divided by 0.1603.80717. So our repayment gives us what? 374.11. So 374.11. So this is how they found the 374.11. Is that okay?
Yes, that's clear.
Then the total interest paid now. So total interest paid. Total interest. So total interest paid is over to NR minus amount. So our L is 3 multiplied by 374.11, then minus 1000. So what is our total interest paid? 3 by 374.11. So it's giving us 1122.33.
1122.33.
And minus 1000.
Which is 122.33.
122.33. So 122.33, that is the aspect of what we are looking at. Okay, so 122.33. All right, so this is how they found this table now. So this table is the year. Beginning amount was 1000. This installment you're paying it goes. This is how much is going. So the 122.33, the same one we found. Then here, the principal that has been paid, or the principal that is paid is the interest for the first year is 1000 times the 6%. The 6% is given here. Okay, so 1000 times 6% is 60. So from the installment of 374.11 minus 60, you're getting the 314.11. So this is how much you have paid towards the principal. then the balance will be 1,000 minus 314.11. 1,000 minus 314.11. So the balance is 685.89. That's how much the balance that you have as at the year end one, which would be the opening balance here, the 685.11. Then you pay the 6%, that's giving us 41.15. Okay, so 41.15, that is the aspect of the principal paid. So the balance is 685.89 minus the principal paid. We are going to have 352.93. Okay, so 352.93. This is what we have here. So 352.93 multiplied by 6%, we pay interest of 21.18. Okay, 21.18. All right, so the 374 minus 21.18, the balance, the principal paid is 352. So this amount subtracting the interest, you're getting 352.93. So meaning the balance as at year 3, we are getting a 0. Yes, please. Okay, so how we are getting what? How we are getting the 1.15? 1.15, you are multiplying the beginning amount using the interest. The beginning amount so this beginning amount, which is this one, the 0.06. So beginning amount multiplied by 0.06. Okay. So this is what we are getting the value from. All right. So, all right. So this is how we have gotten this loan amortization. Okay. So this is just about some of the questions you need to know. And then, of course, we are calculating the effective annual rate. Effective annual rate is a rate that is slightly above the nominal rate. Okay. So when you are getting the effective annual rate, it's actually equal to 1 plus R over M. All right. Okay, so 1 plus R over M. Whatever we are doing here, to the power M minus 1. So M is the number of compoundings. M is equal to number of compoundings. Okay. So from here, you can read the question for us. Question number 10. What is question 10 saying? You can read for us, please.
Question 10. What is the effective annual rate on a loan where interest is compounded monthly and the nominal rate used is 12% per annum? where the M or the monthly, where M is 12 or the monthly rate is 12.
Okay, so monthly rate is 12. Okay. So monthly rate of 12. Yeah, so what is going to happen here is that we have the effective annual rate in this case. For effective annual rate, what is going to happen here is that we will be able to say 1 plus our R is 0.12 over 12. Whatever we are doing here to the power 12, then minus 1. So our effective annual rate will give us what? 0.12 divided by 12 plus 1. So it's giving us
1.01
1.01 to the power 12, and whatever you do minus 1.
minus 1, which is 0.1268 or 12.7%.
Yeah, so then whatever, yes. So you are very right. So this is giving us 4.68%. Okay. All right, so this is what goes on. Then if we go to question number 9, what is question 9 saying? Okay, question 9 says what?
A bank offers to lend you $1,000 if you sign a note to pay 1,610.5 at the end of 5 years. What rate of interest is the bank charging you?
Okay, so we are going to use this formula. Future value is equal to present value 1 plus R the power n 1610. There's a point there. Then there's 1,000 here. Then 1 plus R the power 5. So here, okay, 0.50. All right, so you can divide by 1,000, 1,000. So what are we getting here? 1610.5 divided by 1,000.
Which is 1.6105.
1.6105, which is equal to 1 plus
1 plus
R
R to the power 5.
So you do what? So what you do is you multiply by 1/5.
1/5.
Even here, 1/5. So that one and that one goes 1 plus r. 1/5 is the same as 0.2. So we are getting 1.0999. So 1.0999 minus 1 is equal to r. So meaning that this is it, 0.0999 r. So 10% is equal to r. All right. Is that clear?
That's clear.
Okay. So there's other questions that we need to. So if you want to find an example on the annuities we looked at, future value of annuity of 200 paid at the end of each year for 2 years, semi-annually. So on semi-annually, so on the semi-annually, right? So you're going to say future value is equal to annuity factor, so it's amount 1 plus r over 2 to the power 2n minus 1 over r over 2. So our future value will be equal to 200. Then 1 plus, so 1 plus what? 0.1, that's 10%, is 0.1. So 0.1 divided by 2 over 0.05. Okay. In the power, so there's a 1 here. Take note. There's a 1 here. In 2, only 2 years, minus 1. All right, so our future value of the semi-annual annuity will be 200 here. Then only, okay, 1.05 to the power of 4. Minus 1. Then over 0.05. Okay,
And you
so
multiply that by 2.
is there a question?
No question.
So this will be just 200 on 4.3
310
on 0 on
125.
okay, so it's 862
0.03.
0.03. Okay. All right, so this is what is going on as you are looking at this kind of question. So it's just about which formula to use as we are, because time value of money is very cardinal in terms of